All right, so you sent over some research on AI that can understand images and video.
Right.
But it's also somehow way more efficient than anything out there. We're diving into something called NVILA today.
Okay.
And I'm really eager to unpack what makes it so special.
It's pretty fascinating. It
Yeah.
stands for NVILA, Efficient Frontier Visual Language Models.
Okay.
And it's really pushing the boundaries of what's possible with AI.
Now, this deep dive is based on a recent research paper
Yes.
from a team at NVIDIA, MIT, and a whole bunch of other universities.
Yeah, a lot of big names on this one.
They've actually made the research incredibly accessible.
I noticed that.
You can find links to the code, the model itself on Hugging Face,
Wow.
a demo,
Really?
even a subscription option right at the top of the paper.
That's really cool. They're really invested in making this technology open and collaborative.
I think so.
It seems like it.
Yeah.
So to get to the heart of your deep dive,
Okay.
why is NVLA such a big deal?
Well, the research claims some pretty impressive efficiency gains.
Okay.
We're talking 4.5 times faster training, using less memory.
Wow.
It almost sounds too good to be true.
Yeah.
Like finding a performance car that also gets amazing gas mileage.
That's a great analogy.
Yeah.
The thing is,
Yeah.
current visual language models, VLMs,
Right.
they're notoriously resource intensive.
Right.
Imagine trying to train one of these things on your laptop.
Oh my gosh.
You'd be waiting forever.
The paper mentions that training a standard 7 billion parameter VLM can take up to 400 GPU days.
Yeah, that's not practical for most people.
Not at all.
And it's not just the time.
Right.
It's the sheer computing power you need.
Yeah.
Many VLMs need an insane amount of memory.
I can imagine.
Way beyond what an average computer can handle.
So,
Yeah.
how does NVILA overcome these limitations?
That's the million-dollar question.
Right.
And that's where the scale then compress strategy comes in.
Yeah.
And it's actually pretty ingenious.
So walk us through how that works.
So it's a two-step process.
Right.
First, NVILA actually scales UP, the resolution of the images and videos it analyzes.
Okay.
By capturing more visual detail.
Ah.
It achieves much better accuracy, especially for content that has a lot of text.
Oh, interesting.
They're seeing improvements of up to 30% in some cases.
So bigger IS, better.
At least when it comes to resolution.
Right, at least when it comes to resolution.
Right.
But wouldn't that make the computational demands even higher?
You would think so, but that's where the compressed part comes in.
Go ahead.
NVILA reduces the number of visual tokens that AI has to process.
Now, for those of us who aren't knee-deep in AI every day,
Sure.
can you explain what a token is?
So think of tokens like the building blocks of information that AI models work with.
All right.
You have text tokens representing words,
Uh-huh.
and then visual tokens representing pieces of an image or a video.
Okay, so NVILA compresses these visual tokens to be more efficient.
To be more efficient.
How does it actually go about doing that?
So it uses both spatial and temporal compression.
Okay.
Spatial compression is like taking a large image file and shrinking it down.
Got it.
Temporal compression is like taking a video and averaging similar frames
Okay.
to remove redundancy.
So it's kind of like summarizing a really dense textbook.
Yes.
You keep the key points,
Right.
but in a much more concise format.
Exactly.
Yeah.
And the results are really impressive.
Okay.
NVLA manages to outperform previous models in both accuracy and efficiency.
It's remarkable.
It is.
But from what I'm gathering, the efficiency magic doesn't stop there.
It doesn't.
NVLA actually gets pretty selective about its training data, right?
Yes, they use something called delta loss
Delta loss.
to prune the data set.
Interesting.
It's a really clever approach.
Okay.
Essentially, they train a smaller student model,
Okay.
and they use it to identify examples that the larger model finds either too easy or too confusing.
It's almost like having a study buddy
Yes.
who helps you focus on the most important material for the exam.
Exactly.
Yeah.
By filtering out the noise in the data,
Uh-huh.
NVLA gains significant efficiency without sacrificing accuracy.
That's pretty amazing.
It is.
They found that they could prune 50% of the data with minimal impact on performance. Now, that's what I call some serious decluttering.
Right.
So we've got the scale then compress strategy and the data pruning with delta loss.
Right.
What other tricks does NVLA have up its sleeve?
Well, NVLA also leverages a training technique called FP8,
FP8.
which is a lower precision number format.
And what does that do exactly?
It allows the model to train much faster,
Okay.
especially on the newer NVIDIA GPUs
Uh-huh.
that are specifically designed for FP8.
So it's kind of like having a turbocharged engine that can churn through data at lightning speed.
Exactly.
But don't worry, NVLA isn't just for people with those high-end
Oh,
GPUs.
right.
What about the rest of us who are working with more standard setups?
NVILA is surprisingly adaptable in that regard.
That's good to hear.
They've made fine-tuning much more efficient
Okay.
by using techniques like LoRa and layer norm.
Okay.
These techniques reduce memory usage without sacrificing accuracy,
Uh-huh.
which means you can fine-tune NVILA even on a regular consumer-level GPU.
So it's like having a modular toolbox.
Exactly.
So you only need the tools specific to your project.
Right.
That's a relief.
Yeah,
But what happens when you want to actually put the model to work?
right.
VLMs can be pretty bulky, right?
They can be.
Wouldn't that make them difficult to deploy in real-world applications?
That's a great question.
Yeah.
And it brings us to another key innovation in NVILA, quantization.
Okay. I have to admit, quantization sounds a little intimidating.
Yeah, it's a mouthful.
Can you break that down for us?
Think of it like compressing a large file to make it download faster.
Okay.
NVILA uses quantization to make its model smaller and faster for real-world use.
And what kind of performance boosts are we talking about here?
With quantization, NVILA can be up to 2.8 times faster.
Wow.
This means it can run on devices like laptops and even robots.
Wow, that opens up a whole world of possibilities.
It does.
But hold on.
Yeah,
I have a feeling we're just scratching the surface here.
I think so too.
NVILA isn't just about efficiency, is it?
It's not.
It's got some other pretty impressive capabilities, right?
It does.
Yeah.
It does. You're right. The research highlights some additional capabilities of NVILA that are pretty remarkable. For example, it excels at temporal localization.
Temporal localization.
Yeah.
Okay, you've definitely got my attention.
Okay.
What exactly does temporal localization mean in this context?
Imagine you're looking for a specific moment in a video, like the exact scene where a game-winning goal is scored.
Yeah,
NVILA can pinpoint that moment with incredible accuracy.
that's pretty amazing.
Yeah.
It's like having a supercharged search function for video content.
Right.
What other surprises are in store?
The paper also highlights NVILA's potential in robotic navigation.
Okay.
Picture this. You give a robot a set of instructions, and it actually understands what to do, navigating a complex environment with ease. NVILA has the potential to make that a reality.
Wait, robots that can understand instructions?
Yeah.
That sounds like something straight out of a sci-fi movie.
It may seem futuristic,
Yeah.
but it's becoming increasingly possible
Wow.
with these advancements in AI.
Okay.
And the applications go even further.
Okay.
Researchers are exploring NVILA's potential in medical imaging.
Now that's an area I'm particularly interested in.
Yeah.
How could NVILA be used in healthcare?
Think about a doctor analyzing medical images. NVILA could assist them in interpreting those images, potentially leading to more accurate diagnoses and personalized treatment plans.
That's incredible.
It is.
It sounds like NVILA is really pushing the boundaries of what AI can achieve.
Right.
And all of this while being incredibly efficient. You mentioned earlier that it matches or even surpasses the performance of other leading VLMs. Can you give us some specific examples of how it stacks up against the competition?
Absolutely. The research paper details how NVILA performs on a range of benchmarks, and the results are quite compelling. For image understanding tasks, it excels in tests that require complex reasoning and knowledge.
Can you give us a specific example?
Take the MMMU benchmark, for instance. This benchmark tests a model's ability to understand and reason across multiple disciplines. NVILA achieves state-of-the-art results on this benchmark, even outperforming models that are much larger and more complex. It's like a David versus Goliath story in the AI world.
That's pretty impressive.
Yeah.
What about video understanding? How does NVILA fare in that domain?
NVILA shines in video understanding as well, especially when it comes to processing longer videos on the Video MME benchmark, which tests a range of video analysis tasks. NVILA sets a new state-of-the-art, demonstrating its ability to handle complex video content with remarkable accuracy.
So it sounds like NVILA is a true all-rounder, excelling in both image and video understanding. But let's not forget about the efficiency aspect. You mentioned that it's significantly more efficient than previous models. Can you quantify those gains for us?
Certainly, the research paper provides detailed comparisons of NVILA's efficiency against other leading models when it comes to training speed. For example, NVILA is 4.5 times faster than the baseline model, and during fine-tuning, it requires 3.4 times less memory. This makes it much more accessible for researchers and developers who may not have access to high-end hardware.
Those are some pretty substantial efficiency gains.
They are.
What about inference speed?
Uh-huh.
How quickly can NVILA process new data and actually generate results?
That's another area where NVILA excels thanks to optimizations like quantization and a specialized inference engine. It achieves up to 2.8 times faster inference speed compared to other state-of-the-art models.
Wow. So to recap, NVILA is faster to train, requires less memory, and can process new data more quickly, all while maintaining or even improving accuracy. It's a pretty strong case for why it's such a groundbreaking development.
I couldn't agree more. NVLA represents a real paradigm shift. It has the potential to change how we develop and deploy AI models in the future.
Speaking of the future, what's next for NVLA?
Yeah.
Do the researchers have any plans for further development or improvements?
The research paper mentions several exciting directions for future work. One area they're exploring is new techniques for token compression. They're looking to push the boundaries of efficiency even further. They're also planning to investigate new applications of NVILA, particularly in areas like robotics and healthcare, where its unique capabilities could be truly transformative.
So the future for NVLA looks bright.
Very bright. I'm eager to see what new discoveries and breakthroughs emerge as researchers continue to explore its potential.
You know, it's really encouraging to see researchers prioritizing open science and collaboration like they have with NVLA. You mentioned earlier how accessible they've made this research. Can you talk a little bit more about why that's so important?
Open science is vital for accelerating progress in any field, and AI is no exception by sharing their code models and findings openly. The researchers behind NVILA are enabling others to build upon their work. It fosters a collaborative ecosystem where innovation can flourish.
It's like planting a seed and creating an environment where it can grow and thrive.
Exactly.
And who knows what amazing things might spring from that.
That's the beauty of open science.
Well, I think we've covered a lot of ground in this deep dive.
We have.
We've explored NVILA's key features, its impressive performance on benchmarks, its remarkable efficiency, and its potential to revolutionize various industries.
It's been a fascinating journey.
Now, turning our attention back to you, you sent us this research on NVILA, so I'm curious to know what sparked your interest. What possibilities do you see this unlocking for you?
That's a great question. It really depends on what you're passionate about and what problems you're trying to solve. If you're a researcher, NVILA offers powerful new tools for exploring visual language understanding in ways that were previously impossible.
And for developers, I imagine NVILA makes building AI applications that can truly see and understand the world much more attainable.
Definitely imagine building applications that can analyze video footage in real time, or robots that can understand complex instructions and navigate challenging environments. NVILA opens doors for that kind of innovation.
And even for those of us who aren't directly working with AI, NVILA represents a significant leap forward. It brings us closer to a future where machines can interact with and understand the visual world just like we do.
Exactly. It has the potential to impact our lives in countless ways, from healthcare and transportation to education and entertainment.
So to wrap this all up, NVILA is breaking down barriers in AI, proving that you don't have to sacrifice efficiency for accuracy. It really seems like it could be a game changer.
I think so too. NVILA's potential to revolutionize various fields is truly exciting.
Now here's a final thought-provoking question for you to ponder. What problem could you solve with a faster, more efficient, and incredibly capable AI like NVILA?
We encourage you to explore the links provided in the research paper. You can delve into the code, the models, even try out the demo.
Let us know what you discover. We're excited to hear about the amazing things you'll do with NVILA.